Welcome to this new video of Module 2, IPv4 address exhaustion, coexistence, and transition. In this module, we'll now talk about general recommendations relating to the exhaustion of IPv4 addresses and the transition to IPv6. We'll discuss the following topics: IPv4 address exhaustion, the growth of IPv6, and planning the transition and coexistence. IPv4 address exhaustion. As we have seen, IPv4 address exhaustion is now a pressing reality everywhere, including Latin America and the Caribbean. Although much has been said about the need for IPv6, and despite the fact that every internet actor has repeatedly stressed the importance of this issue, IPv6 deployment has been delayed to the point that we now find ourselves in a situation where we not only need to deploy IPv6, but we're also faced with IPv4 exhaustion. In addition to accelerating the process of IPv6 deployment, this means that deployment strategies must now consider a new factor: growth of IPv6. IPv6 deployment is now a reality. IPv6 traffic is on the rise, just as IPv6 support in hardware and software, and IPv6 training for technicians and engineers. IPv6 traffic is growing exponentially, currently representing close to 5% of global internet traffic, although in some countries or regions, IPv6 is well over this figure. More and more networks use IPv6 only or are only considering implementing IPv6 while trying to use transition mechanisms to provide connectivity to legacy IPv4 content. As we have seen, these mechanisms have their limitations. Thus, if we don't want to become invisible or hazy to an increasingly larger part of the internet, we must be reachable via IPv6. In addition, new technologies such as wireless sensor networks are being developed, which are only available for protocols defined over IPv6, such as 6LoWPAN. It seems clear that IPv6 is the way of the future and that we must be properly prepared. Planning the transition and coexistence. The transition to IPv6 and its coexistence with IPv4 must be carefully planned, adapting the process to each particular situation. Each organization must be responsible for its own infrastructure and implement IPv6 just as it implements any other new technology. The complexity of this project will depend on the size of each network, its components, internal processes, available budget, and even the desire to actually implement the new protocol. Certain aspects will always need to be considered. Is it possible? In other words, a viability analysis. We can say that it is indeed possible, and it is always possible to offer IPv6 connectivity one way or another, given the multiple tools such as transition mechanisms that are available and that can be applied. The real question is whether the viable solution is good enough for our purposes. Why? The first step is finding a reason to make it happen. Recommendations or regulations imposed by the government or other bodies staying on the front line of technology, looking for business opportunities. Today, the question is not really whether or not to deploy IPv6, but when to deploy version 6 of the IP protocol. Who? We must identify the organizations, individuals, and departments that will be involved in this project. How? Identify and define tasks and phases, appoint a project coordinator, etc. When? Time frames must be established, as IPv6 implementation is becoming increasingly urgent. As in any project, an ultimate goal and a scope must be defined that will allow us to determine when to wrap up the project. As mentioned earlier, several deployment phases may be defined, each of which will have its own goal. There are also other, more concrete considerations that must be addressed. Firstly, proper IPv6 training for those involved in the process. This is an important step that needs to be completed in the early stages of the project, as it will make for a smoother transition. Another important aspect is to analyze the existing network, including network topology, services, technologies, short-term changes, and so on. Part of this analysis will consist of preparing a full inventory of the elements that make up the network. Then, it is important to define which functionalities are needed to implement IPv6 and which are supported by the elements included in the inventory. An addressing plan should also be prepared in this new IPv6 space, based on a new IPv6 prefix we need to obtain for our network. If possible, we should plan for native IPv6. A cost estimation should also be considered to determine just how much IPv6 implementation will cost. Here, we need to remember that early planning can reduce transition costs, as a large part of the cost of software and equipment renewal can be minimized if they are included in our natural renewal cycle. We must also consider the cost of human resources for both the implementation and the operation of the network. We must establish a strategy. We must decide whether we will use IPv6 only, dual stack, or other mechanisms, in which parts of the network, in which order, and so on. The security policy must also include all IPv6 related topics. The level of security in IPv6 should be equivalent to the level in IPv4. And of course, include any new IPv6 implementation in management, monitoring, and accounting systems. Testing must also be conducted. Pilot tests to check that the new technologies are working properly and can be moved into production. The goal is for this transition to be transparent to end users who do not really care whether they're using IPv4 or IPv6. One very important consideration: IPv6 should be seen as the first step towards the network of the future. IPv6 is not a goal in and of itself. Instead, we need to think of new services, new technologies that use IPv6 and that will allow us to take advantage of all the work we are doing. This process is also an opportunity to improve our network, our services, our management. We can improve what we had with IPv4. The long-term goal might even be to abandon IPv4 and have an IPv6 only network and services. When planning our strategy, we should also consider dual stack as our first option. Where dual stack is not an option on an IPv4 network, we have seen that we can use different solutions. One of these solutions is 6 in 4, which is a very simple and sometimes very useful. One of these solutions is 6 in 4, which is very simple and sometimes very useful. 6 in 4 can be used for testing. However, 6 in 4 is not scalable, as it is point-to-point and requires manual configuration. As a temporary solution and for testing purposes, we can also use a tunnel broker to provide connectivity to a small network, or 6RD, which is a scalable, easy-to-implement solution provided that it is properly supported by CPEs. 6RD is a good temporary solution for ISPs. But let me stress once again, the word is temporary, as in the future the ISP will have to migrate to native IPv6. We have IPv6 infrastructure. DS Lite offers a scalable solution. If we have IPv6 infrastructure, DS Lite offers a scalable solution. DS Lite automatically creates multi-point tunnels and optimizes the use of public IPv4 addresses provided that it is properly supported by the CPEs of our clients. NAT64/DNS64 and their evolution 464XLAT are also options. The latter will be a solution for IPv6 only networks. Thank you for your attention. We have just watched the video on General Recommendations. This is the end of Module 2, IPv4 Addressed Exhaustion, Coexistence, and Transition.